Hi guys, so this is our last extension video. This one really is going to tie into the one from last week, so if you did not watch last week's, you probably want to do that before this one, because this one may not make a lot of sense otherwise. So what we're going to do is look at some simple kind of trig equations. You're going to get a lot more detail about this when you get into pre-cal. You're also going to look at some more specifics on these inverse values once you look at the inverse function and what it looks like. You'll talk about like your principal inverse values, and you're going to get into a whole lot more detail. So all we're going to look at today is really a broad overview of these inverses and kind of relating it to what you did back in geometry. So we talked about inverses a lot this year in this class. Well, again, inverse is a different operation. You're switching x and y. You did this back in geometry. Like, let's say you knew a triangle, and you knew that this was 3 and this was 2, and you were trying to find this angle. Well, you set that up as tan inverse of 3 over 2 is equal to that angle. So same idea here. All right, so something like this first one, sine x equals root 2 over 2. In order to solve that, you would have to do sine inverse of root 2 over 2 is equal to x. Well, to answer that question, we need to look at a couple things. First of all, we need to look about how we want to write our solution. This tells us it wants x to basically be in between 0 and 2 pi. 0 is included, 2 pi is not. That's basically saying somewhere on that unit circle that we did in the last extension video. So wherever sine is root 2 over 2 on that unit circle is your answer. Well, go ahead and look back at that circle. Remember, sine corresponds to the y-coordinate. So you're looking for where on your circle is there a y-coordinate of root 2 over 2. That's positive. And you'll probably notice there are 2 places. You've got one over here at pi over 4, and you've got another one over here at 3 pi over 4. Now, down here and down here, you have the same absolute value, but those were both negative. So your 2 answers here were pi over 4 and 3 pi over 4. And that's it. So again, the better you know that unit circle, the easier it's going to make a lot of things for you. All right, look at the next one. Next one's already set up that way. Cosine inverse is -1. Okay, so again, look back to your unit circle. Cosine corresponds to the x-coordinate. So when is the x-coordinate -1? Well, if you look on your unit circle, you'll notice there's only one place where that happens. The x-coordinate is -1 over there at pi. So your answer is pi. All right, so again, simple equations here. Now you're going to see a lot more complicated ones when you get into pre-cal that are going to use a lot more things that we're not talking about here. This is just to introduce you to the basic concept, okay? Just because we've done a lot of solving equations this year and we've done inverses, I kind of want to tie it together. But what you do here is get sine by itself. So sine x is 1/2. That means our answer would be sine inverse of 1/2. So that means on my unit circle, when is the y-coordinate 1/2? And again, you'll notice 2 places. Over here at pi over 6, and over here at 5 pi over 6. So you have 2 answers here. All right, now let's say you forgot your unit circle. Okay, let's say you didn't know how to figure this out. But because you can't remember unit circle, but you can still work it out algebraically. So sine inverse of 1/2. Okay, so that means that your opposite is 1, your hypotenuse is 2. Well, if I do Pythagorean theorem here, a squared plus b squared is c squared, my missing side is root 3. Well, that sure looks like a 30, 60, 90 triangle. That means that that angle there is 30. 30 degrees in radians, pi over 6. To get the other one, we have to figure out where else sine is positive. Well, our little all smarties take calculus acronym helps us to remember that. Sine is positive in quadrant 2. So I can also draw that reference angle in quadrant 2. Opposite is 1, hypotenuse is 2, Pythagorean theorem, that's root 3. It'd be negative based on where it is, but that doesn't affect our angle. And that tells me that this little reference angle there is 30, or pi over 6. So if that's 30 or pi over 6, that angle right there would be 5 pi over 6, pi minus 5 pi over 6. So again, if you ever forget your unit circle, that's how you can come back up with those values algebraically. All right, and looking at this last one, again, get tangent by itself. All right, so tangent, remember, is that y over x ratio. So we're looking for where y divided by x is equal to -1. Well, first of all, it's negative. So that tells us it has two possible quadrants. Tangent's positive in quadrant 1 and quadrant 3. So it's not in those two. So we know it's going to be somewhere in quadrant 2 and somewhere in quadrant 4. Y divided by x giving you a value of -1 means y and x are the same value. And that happens at 3 pi over 4 and 7 pi over 4. So those are your two solutions here. Now again, when you get into pre-cal, you're going to look at something called your principal inverse value, which is going to be a little bit of a different way of finding this solution. This one specifically is your answer because the original directions said to find your answer between 0 and 2 pi. Now that's going to change a lot in different problems. That interval may change. It may say to find that principal value. It really kind of depends. So what we're going to look at now is how to find all of the possible values. Because as you know, those were the only solutions within that certain interval, but there is really an infinite number of answers to these questions. So let's start with this first one. All right, again, I'm going to rewrite this as an inverse. So again, we're looking for where cosine is negative. So cosine is negative in quadrants 2 and 3. Okay, so there's two places where you can find this. We're looking for the x coordinate to be negative. So that's going to happen. One of those places is over here at 3 pi over 4. But what we want to do here is we're going to find all of the possible answers. And what I mean by that is that 3 pi over 4 is not the only place where this is true. Every coterminal angle to 3 pi over 4 is also going to have that value. So the way I'm going to write this is 3 pi over 4 plus 2 pi n. Because n can be anything. It could be 1, it could be 7, it could be -3, it could be any not necessarily natural number, sorry, or else I'd say plus or minus, any integer. So we can add or subtract 2 pi as many times as I want to. If you want to write plus or minus 2n, that's fine. I've always just done plus 2 pi n and assumed n could be negative. So that's one answer. Your other answer is down here in quadrant 3. So you'll notice that x coordinate is negative root 2 over 2 at 5 pi over 4. So you also get 5 pi over 4 plus 2 pi n. So that represents every possible answer to this equation. Well, now after you find that, what it wants you to do is it wants you to find the first three positive values. So basically, we already found two of them. So if I start at 0 and I go around, I hit 3 pi over 4. That's my first one. I keep going. I hit 5 pi over 4. I keep going, and then I hit 3 pi over 4 again after making that full circle. So that third value would be 3 pi over 4 plus 2 pi. So 3 pi over 4 plus 8 pi over 4, which would be 11 pi over 4. And those are those first three positive values. Again, it keeps on going. There's an infinite number, but 3 pi over 4 is the first positive one, and then it just continues from there. All right, now looking at the next one, tan inverse of root 3. So again, that's going to be a y divided by x of a square root of 3 value. So go back, check out your unit circle. You're going to find two places where this happens. One of them is in quadrant 1. One of them is in quadrant 3. And if y divided by x is root 3 over 2, well, that's root 3 over 2 divided by 1/2. Because that's root 3 over 2 times 2 over 1. So that's where we're going to find it. So your y coordinate then is root 3 over 2. Your x coordinate is 1/2. And that's going to happen at pi over 3 and 4 pi over 3. So again, if you want to write that answer to show all those possibilities, you could do pi over 3 plus 2 pi n and 4 pi over 3 plus 2 pi n. But you may notice there's actually a faster way to write this total solution. Pi over 3 and 4 pi over 3, it's actually kind of a special little relationship here. They're already exactly pi apart. So I don't need to add 2 pi to both of them. I just need to keep saying pi over 3 plus pi, plus pi, plus pi, and they'll keep giving you those different values. That's kind of a shortcut way for writing that. All right, so then finding those first three positives, again, I would start at 0. First one I'd hit is pi over 3. Then I would keep going. Next one I would hit is 4 pi over 3. Then I'd keep going. I'd do that full circle before hitting pi over 3. So adding that full circle to it would put me at 7 pi over 3. All right, and then this last one, again, let's solve to get sine by itself first. So I'm doing sine inverse. So I'm looking for where the y coordinate is 1. Well, in this case, there's only one place where that happens, and that's up there at pi over 2. So that general solution of all of those things is just pi over 2 plus 2 pi n. So then those first three positive values, again, I would start at pi over 2. Then I'd have to do a full circle to get my next one. So a full circle would be pi over 2 plus another full circle, 9 pi over 2. All right, so again, that's kind of just a brief introduction to inverses. You're going to do a lot more with these equations. You're going to do a lot more with inverse values. Again, you're going to talk about those specific principal values. You'll look at some different intervals, but this is really just showing you guys how the unit circle not only helps you to evaluate trig functions, that unit circle also helps you to find those inverse values when you go backwards. So that's really it for these extension videos. Again, if you have questions, feel free to reach out over email.